Hey yo, what's up, YouTube? It's your boy. It's your what? It's your boy. It's your boy. JOSHABRAHAM. Let's fucking go. 1 hour of general organic chemistry. Organic chemistry. I'm late. Yeah, I'm a bit too late though. Okay, little bit late. Baby, baby, How do I start? Uh, organic bit. Yeah, open the PDF. That's how you start, right? You open the PDF. That's how you start. Not gonna lie, my past experience on cloud AI, not the best. What happened to Discord? Why did it just shut down? Dude, Discord has updates every single time. Oh, bro. There's construction going on? So construction going on? Yesterday? Yesterday. Okay, 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 okay. How is the uh FPS back? No? Oh, okay. It's better than before. Should I use Claude again? Because Claude is not good. It's so slow. I thought GPT was slow. Claude is slow. Hey Siri, set a timer for 15 minutes. So today the class was till here. No, went past here. Till here. No, till here. 43. I'm nowhere close. But I will get there. Okay, so spectroscopy means measurement using light or waves, and spectrometry is at least the mass spectrometry means analysis using mass. Exactly, okay. And it studying how matter interact with electromagnetic radiation, measuring and quantifying specific properties of a sample. Doesn't involve light at all. Okay, okay. Okay. Uh, Mass spectrometry fits the spectrometry label because you're measuring mass, but there are no wave or light interaction happening. Instead, you're ionizing the molecule, blasting it with electrons or other methods, accelerating the fragments through a magnetic electric field, detecting them based on their mass to charge ratio. It's essentially weighing molecular fragments rather than measuring light absorption. Okay, okay, I kind of get it. I kind of get it. Kind of get it. Got it. Yo, I'm still having a hard time focusing. Determining structures by spectroscopy, basic principles, electromagnetic spectrum. And I was given Mm-hmm. What's this noise? Construction. Of course, construction. No, from ever over. Do you have to show the whole thing? I don't think so. I don't know. Ads. Fucking ads. Frequency versus wavelength, the inverse relation: higher frequency, shorter wavelength; lower frequency, higher, longer wavelength. Higher frequency, shorter wavelength. I'm getting a call. Just a minute. Ooh, yo, Muhammad Fahad Shehab. What's
Hi
up?
Pantera, hear you.
Yeah, I was, I was attending a call, but now it's good. What's up, Muhammad Fahad Shehad? How you doing? Is it your first time checking the stream out? I don't think so. I felt like I seen your name before.
Nice.
Nice. Nice, yeah. Yeah, I feel like it's your first time checking out the stream, right? Is it? I don't. Muhammad Fahad Shehzad. What made you click the stream? Was it the organic chemistry? Were you preparing for organic chemistry or something? Shorter wavelength, higher frequency, shorter wavelength, higher energy. All three are linked. You can't change one without changing the others. You nailed the core con. Here's the deeper connection between the frequency, higher frequency, shorter wavelength, higher energy. Mm-hmm. So here, higher frequency means higher energy. But somewhere else, I read that higher frequency means lower energy. Uh, okay, let me. So I kinda get this concept, but I was wondering. Fact that let's consider pendulum and it swings at first. It has higher
Yo.
Mikhailash
Thought to
Mikhailashki
swing by.
thought to swing by. I appreciate you for checking out the stream, man. It means a lot. Let me guess, you were the fixed gear, right? Tell me that's right. You also drive a fixed gear, right? Apologies for the latency. I feel like there's still a 20-second delay or something.
Yes.
Yes! I got it right. I feel good. How you doing? It's been a while, I guess. How you doing, bro? How are things going? Is everything good?
The delay is crazy.
Yeah. How much is it? Like 10-second delay? I feel like it's about 10 second that's the delay. YouTube stream is a bit slow compared to Twitch and stuff. It has higher or longer wavelength. Then it keeps on losing energy each time it swings.
I've been doing fine and it's a 20-second delay.
It's a 20-second delay, yo. The setting is ultra low. Stream latency setting is ultra low. I mean, I also noticed my. Okay, now the camera is not that slow, but I also noticed that. I feel like the most probable reason would be my computer being slow. Because the setting is ultra low. So I was thinking, a pendulum swings at first, it swings with lower frequency or a longer wavelength, right? Yep. Then it keeps losing energy each time it swings, re- 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 uh, reaching. Well, Mikhailash, I'm glad that you're doing fine. The stream latency, it's just weird. It's each time it swings, reaching lower and lower wavelength, but losing energy for lower wavelength. How is this logic compared to the electromagnetic waves? What? Hey Siri, set a timer for 15 minutes. Where's the where's the timers?
Maybe because I live in the other side of the globe.
The 20-second delay? I don't know. I mean, from my side, I feel like it's the computer being slow because it's a laptop. I'm streaming on a laptop, plus, I am streaming my phone's video footage along with the stream, right? So maybe this little thing is having a little bit hard time, but hey, I gotta say, I'm glad that I can even at least stream. So I'm not complaining too much. But YouTube, you could get this shit better. You could make this work better, okay? This is a really sharp observation. Go shut the fuck up. The pendulum. What's happening here? When a pendulum swings and loses energy, what's actually getting smaller is the amplitude, meaning how far it swings left and right. The arc gets shorter and shorter until it stops. The frequency of a pendulum, how many swings per second, actually stays almost the same throughout. A long pendulum swings slowly, whether it's swinging wide or barely moving. It doesn't speed up its oscillation as it loses energy. So pendulum losing energy equals smaller amplitude, not the higher or lower frequency. Okay, okay. Amplitude and frequency are completely independent properties that carry different types of information. Amplitude, how intense bright the wave is, how much energy is being carried in terms of quantity. Quantity. Frequency, what type of electromagnetic radiation it is. And this is fixed and doesn't change. This is fixed and doesn't change as energy is lost. What type of electromagnetic? Wait, I need more proof on amplitude. Yes, I am a bit on the slow side, so I keep forgetting these terms. Amplitude, frequency. So that's amplitude. High frequency, okay. Short wavelength, high frequency, okay, okay, okay. The number of higher frequency means higher energy. Yeah, okay. So frequency is proportional to energy, and wavelength is inversely proportional to frequency and energy. I should write it down. Yep, I should write it down. So we start with the happy go okay. I'll be fine once I get it. I'll be good. Oh man, I feel like an old person for using an older tablet. But hey, it works, it works. That's the story. End the story. Organic, biological. You know whose notes are these? This is I need to get a bigger text. Wie kann man das anfangen? So, spectroscopy. Spectroscopy and spectrometry. Wait. Matter interact with electromagnetic radiation. Okay. Oh man, when I please no, it's not working. Okay. So spectroscopy, spectrometry, spectroscopy, interaction of electromagnetic waves with matter slash atoms. Spectrometry. What was that exactly? Analysis of of a molecule, mass spectroscopy. No, spectrometry, not spectroscopy, spectrometry. Spectrometry, say it with me, spectrometry. Analysis of a molecule using mass mass fraction of the molecule, etc., to determine the molecule. So that's spectrometry. The other one is spectroscopy. There are three types of spectroscopy: X-ray, not the gamma ray. X-ray. Not gonna lie, I forgot. X-ray, UV, IR, NMR. X-ray, spectroscopy. What's the other one? UV spectroscopy. IR spectroscopy. NMR spectroscopy. And X-ray diffraction. The scattering of X-rays gives bond lengths and angles. But I also want to mention the part where X-ray spectroscopy is where it only works on crystallized molecules or crystals. You know what? I'm gonna stop sharing the screen just for me to get an exact. Where's my mouse? Studying how matter interacts with electromagnetic radiation, light, radio, spectrometry. Okay, okay. So before I continue, can you give me the summary? A summary on the 4 types of spectrometry that was on my notes. It's out. Wave used X-rays, very short wavelength. What it does scatter off electron clouds in a crystal, gives exact 3D atom position, bond lengths, and bond angles. That's what X-ray does. Let me wash my hands. I feel like my hands are not pretty weird. in here. Y'all gonna make me go all out. Up in here, up in here. Ultraviolet and visible light excites valence electrons to higher energy levels, detects conjugated system and aromatic rings. Excites bond vibrations slash rotations, identify functional groups in the mar. Okay, you know what? I'll look in. I'll look deeper into these in a while. Not right now, because if I start looking deeper into those, I waste a lot of time and no progress. 15 minutes. Okay, I got one more 15 minutes to end this 1 hour session. And boy, I'm so back. I'm so backwards. We gotta fasten things up. X-ray spectroscopy, what does it do? Uses X-ray short wavelength, higher frequency, higher energy waves. Gives precise atomic structure. Let's set a timer for 15 minutes. Gives exact 3D atom positions. How much nanometer was X-ray? 0.1 nanometer. Which scatter of the electron cloud of the crystal bond length and angles. UV spectroscopy, what does that give? ultraviolet and visible. So 0.8 to 10.1. 0.8 to 0.1 uses visible light to ultraviolet light. Zero point 0.8 to 0.1. Does it is it mentioned that it use and visible waves? Okay. Excites valence electrons to higher energy level. Detects conjugate. Okay. Detects conjugated rings. Conjugated bonds systems. Okay. Aromatic excites valence electrons to higher energy levels. Okay. Works by exciting valence electrons to higher energy levels. To energy levels. And yeah, that's how it. Okay, I don't. I just need a brief explanation. That's good enough. Infrared lights. Where would that be? So it would be from point 0.8 to 10 raised to 2. 0.8 to 10 raised to 2 new meter lambda. So these are all new meters. Of course, it's new meter. Excites bond vibration rotations. Identifies functional groups. I should write this down. What's it called? By after learning it by heart. Works by identifying and exciting bond vibrations and rotations. So after exciting these things, it's gonna help us figure out functional Functional groups. Okay. NMR spectroscopy, the main deal. You know what? I'm gonna use this small space. NMR radio waves. So that's like 10 raised to 6 to 10 raised to 10. Nu m. That's low frequency. That means less energy, right? You can't got distracted. Radio waves inside a magnetic field. Radio waves. Flips nuclear spins, reveals atom connectivity and chemical environment. That's not a good explanation. Interaction of radio waves with nuclei in a magnetic field. That's better. Interaction of radio waves with a nuclei in a magnetic field. External magnetic field, but yeah, that's just how it is. What did they saw, bro? What did they... So that's written. Now, electromagnetic spectrum. How do I draw this without looking? Frequency in hertz, lower to higher frequency radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays, cosmic rays. Dude, cosmic rays, that's gonna be even better at helping us finding out. Cosmic cosmic rays is gonna help us better in spectroscopy, right? Bruh, if you use the same logic, bruh. Violet, indigo, blue, green, yellow, orange, red, Vibgyor. Frequency. So red has the lowest frequency and violet has the highest frequency. Um, wavelength, red has the highest wavelength. What does that mean? That means yeah, difference between okay. So what's the order? Radio waves, microwaves, radio waves, microwaves, infrared infrared radiation, visible light, X-rays, gamma rays, cosmic rays. No, visible light, ultraviolet. Oh, there it's in the name, ultraviolet. Okay. Let me go it again. Let me try it again. Start with I forgot what you start with. Radio waves. Radio waves, microwaves, visible light, no, infrared rays. Radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation or light, X-ray, gamma ray, cosmic ray. Let me do this once more. Radio waves, 15 minutes. Yeah, I know. Radio waves, microwaves, radio waves, microwaves. What else? Infrared. Oh yeah, red. Infrared. Light or radiation? Infrared radiation, visible light, ultraviolet. Oh, red, violet. Okay, that makes sense. Ultraviolet, X-rays,
Bro,
gamma.
I'm leaving. I got a test.
Whoa, who said that? Yo, the fact that you were here, that means a lot. Of course, prepare for the test. All the best, gang. If you don't mind, you could let me know what subject the test is going on. But if you don't have time, that's all good. Appreciate you for checking out the stream, though. Uh, yeah, radio waves, microwaves, infrared, yeah, visible, ultraviolet, X, gamma, cosma. Oh yeah. I'm gonna write this on my own. Let's see how hard it is. Oh, come on. Takes that long to share a screen? Okay. So we start from frequency, high frequency, low frequency, and the opposite. It's not a straight line. High wavelength,
Hey,
low
I brew.
wavelength. Did you say AI? Right now, I won't be able to see the chat because when the screen is shared, my laptop everything is blank. So I'll see the chat after I stop sharing. What was it? So we start with radio waves. Radio waves, microwaves, infrared waves, or radiation, don't matter. Visible light, ultraviolet rays, X rays, gamma, oh no, gamma rays, cosmic rays. Now, if we split the light, Web your wait, Web your, that's good enough. Now the numbers, I don't know the exact numbers, but I guess that was good enough. Yo, Ashik, oh Asif Iqbal, what's up? How you doing? I was not able to stream the like yesterday and stuff, but now we back. Oh, so what are the numbers? 10 raised to 5 hertz. 10 raised to 5 hertz is for radio waves. 10 raised to 5 till 10 raised to 10. 10 raised to 13. Mm-hmm. Okay. I was wondering, should I be learning the frequency in hertz and the wavelength in picometer? Of an electromagnetic spectrum? Yo, Asif Iqbal. I really apologize I couldn't see your chat on time. Hmm. Okay. Frequency, amplitude, wavelength. So that's wavelength, frequency. Yo, I should stop picking my nose. It's not good. From what I heard, picking your nose is a really bad thing to do. Now, I'll stop with the last part. Wavelength, amplitude, and wavelength per unit. Okay. Another question is frequency is the number of wavelength per unit time. Frequency is the number of complete wave cycles passing a fixed point per unit. Okay. Wavelength, amplitude, and okay. I'm gonna stop with this. Manushin. Yo, it's taking a long time just to share the screen. Boing, boing. Oh, it's not good enough. So, starting from here till here would be wavelength. Would be amplitude. And the number of wave cycles That's not good enough. Passing through a point in unit time is frequency. No, that's wavelength, right? Okay. Well, that's it. I'm gonna end the stream. It's been more than 1 hour. It should be 1 hour. Peace out, YouTube. I'm gonna continue in a bit.